Good day everyone, welcome. Today we are going to discuss the last topic of this course, which is the topic 9, that is all about Introduction to Physical Oceanography. So this is for the authors and contributors of this material, and here is for the copyright notice. For the intended learning outcomes, after this lecture and exercises, you the students must have first, discuss the concept and principles of physical oceanography, including its historical background. Next is to discuss the essential aspects of physical oceanography, effects of the sun's radiation, and the ocean properties. And lastly is to define the related terms in waves, tides, and currents, including its significance. We have 8 parts for this lecture. So the part 1 will be all about Introduction to Oceanography. Part 2 is all about branches of oceanography. Part 3 is the essential aspects of physical oceanography. Part 4 is for physical setting. And for part 5 is the effects of sun's radiation. Part 6 is all about ocean water properties. Part 7 is the forces acting on masses. And lastly, for the part 8, which is all about waves, tides, and coastal processes. So without further ado, let's go to the part 1 of this course, which is all about the Introduction to Oceanography. So we all know that oceanography, from the word itself, that it is a scientific study of oceans and seas, or for short term, oceanography is the study of oceans and seas. And oceanography deals with the distribution of oceanic water masses, morphology and relief of the ocean floors, deep zones in oceans, sediments of the oceans, marine mineral resources, oceanic processes, dynamics of water masses, and the role of oceans in controlling the global climate. So masabtan naman siya, no, na mao ni ang ginadeal ng mga studies when it comes to oceanography. So basically or merely, it's all about the study of oceans. And the physics, chemistry, geology, and biology of the oceans are the deep concepts in natural sciences. Okay, since oceans is considered as natural resources, so the natural sciences that studies with the aid also of the knowledge of the physics, chemistry, geology, and biology. So these are the concepts that can be discussed, no, in oceanography, no, labi na sa pag-study sa oceans, including its physics, chemistry, geology, and etc. And as we all know also that oceans are very dynamic. So galihok man siya, no, dili man static ang atong oceans. So naay mga waves, naay currents, naay tectonic plates motions, and so on, no. So oceans are very dynamic and widely distributed water bodies. So dili naman kay sa isa lang ka place na naay water bodies. So all around the world is naa siya water bodies. And the nature and role of oceans are continuously studied by oceanographers, marine biologists, marine engineers, environmental scientists, ecologists, geologists, marine geologists, meteorologists, climatologists, and geographers. No, so since oceans have many aspects to be studied, no, so these professionals are the one who is suitable or responsible rather, no, in studying in every aspects of the oceans, no. So lahi-lahi silang scope, lahi-lahi pilang ilahang study. And oceanography is the one of the oldest subjects of mankind, and even today the subject of oceanography is diversified into many folds and branches, no, kay since dako man kay scope si oceanography rather. So sipak-sipak na siya, or kanang gi-subdivide na ang iyahang or na siya mga branches, nagipang subdivide na ang iyahang main study nga point, no. So mo na yung mga branches, no, sa oceanography. So kay since para mas mapokusan jud siya, no, kung unsa ang nakafocus na study or aspect sa oceanography. And for historical explorations, no, a lot of oceanographic expedition and explanations have been conducted by several groups of people under the support of ancient and modern kings and kingdoms, no. So sa unang panahon, they are exploring the seas, no, labi na sa pagpangita nila og locations or places na pwede nila kuhaan og mga resources, no, such as mga expedition nila Magellan, no, for example. So they are exploring the seas, no, na pwede ba kahaan siya diri ta moagi, diri nga ruta, or some are exploring the oceans just to justify or to confirm that the earth is really round and not flat, no. So na mga expeditions na depende sa isa ka country, no, nga mo suporta for the expeditions and explorations. And all those investigations have helped people over the years to understand the nature of oceans to a great extent, no. So based sa ilahang mga observation from those explorations and expeditions, they can come up with a conclusion, no. For example, nga nakauli sila sa ilahang place, no, gituyok nila ang earth, no. So they can say that the earth is really round, no, and not flat. So ingan ang mga explanation. So nakatabang na sa ilaha sa pag-study on oceanography, no, and ocean explorations and expeditions. So it is progression with many innovations and discoveries even up to today, no. Naadya pa mga explorations, pero mas focus na karon sila sa kung unsay naa sa oceans, under the ocean, the sea floor, no, the ocean floor, kung unsay naa didto, unsay naa nga mga features, no, what is the environment, what is the ecosystem nga naa sa under the ocean. So they are more focused with that. And still there are a lot of things, no, found inside in the deep oceans. So we all know that, no, naa pud sila kaugalingon nga ecosystem, na sila kaugalingon nga habitat in the deep ocean. And according to the source of this slide, the unexplored regions are more than, no, the explored domain. So tungod sa kadako sa extent of the oceans, those unexplored areas are more than, no, mas dako pa compared sa katong nga na-explored na. So ingan na kadako ang extent sa ato ang water bodies. And oceans offer a lot of marine resources, fisheries, mineral deposits, food resources, and energy resources. Yes, indeed, no, oceans can offer a lot to us, no, labi na sa mga, for example, fishing activities. So they can give food to the residents, no, near to that water bodies, no. We have also mineral deposits, no, and many more, no, nga pwede ma-offer sa ocean. And these are much useful to human population of the whole globe to survive. Yes, of course, specifically in food, no, mga fishes. So these are very important, no, to human population to survive. And it is necessary to understand the integrated aspects of the subject of oceanography with available scientific facts, principles, and findings and observations. No, so due to significance of the oceans in the mankind, so even up to today, no, there are many studies that were conducted just to explore the unexplored regions of the earth, of the ocean, rather. So mas na-curious sila sa katong mga unexplored kay unsa pa jud ilain na ma-offer, unsa pa jud naa diri wala na to nahibaw-an, wala pa na-studyhan. So let's go to the branches of the oceanography, which is the part 2. So oceanography is a very vast subject, so wide kay siya, and it has grown over a period of several centuries, and there are many major branches of oceanography. These are the physical oceanography, chemical oceanography, geological oceanography, and biological oceanography. So first, let us discuss all about the physical oceanography. So the physical oceanography is an essential part of the oceanographic analysis. For these studies, the physical conditions that are prevailing in the seas and oceans. So from the word itself, the physical aspects of the oceans are being studied with this branch of oceanography. So it deals with the large-scale physical processes and their effects that are happening within the oceans, the movements, the dynamics, and so on. And the properties of the water masses also may vary on the space and time. So physical oceanography consider all these aspects in projecting the ocean. And lastly, this branch has grown due to historical oceanographic explorations and expedition carried out by several scholars, no, from almost all parts of the world. So they are more uh, curious, no, on the physical aspect of the oceanography. So this branch has been born, no, naborn siya tungod sa pag-study, no, sa physical oceanography. And very essential aspects of physical oceanography are to be understood first. So, indeed, no, when you are studying something, no, you need to investigate first the physical before you go beyond sa another aspect. Kay mo man imong murag mas makita physically or mas ma-touch nimo, ma-observe nimo directly. So, it is very precious, no, to study first the physical aspects. Next is for the chemical oceanography. So another branch of oceanography that studies of everything about chemistry of the ocean, distribution and dynamics of the elements, isotopes, atoms, and molecules. From the word itself, chemical, so the chemistry of the ocean have been focused in this branch of oceanography. So this ranges from fundamental physical, thermodynamic, and kinetic chemistry to two-way interactions of ocean chemistry with biological, geological, and physical processes. So masabtan naman siya. So more on about chemical aspects sa oceans. So chemical oceanography attempts to analyze the interaction between oceans, the lithosphere, atmosphere, and biosphere. Seawater chemistry controls in chemical distribution, components of marine sediments, and chemical controls in biological production. So, dili lang kay chemical or chemistry aspect ang i-consider ni oceanography, but also its interactions with the different aspects and different layers, no? So we say layers of the atmosphere. And next branch is the biological oceanography. So the basic ecological concepts are central to many studies of biological oceanography. So the ecosystem, no, the life that is present in the oceans, no, are being studied in biological oceanography. The study of marine life, the habitat, interactions, abiotic environment, phytoplanktons and primary productions, zooplankton, migrations and changes, energy flow and mineral cycling, marine food chains, food webs, the nectons, no, marine reptiles, mammals, the seabirds present in the oceans, mariculture, benthic plants and animals, intertidal environments, the beaches, coral reefs, estuaries, and mangroves are the one, no, nga focus sa study when it comes to biological oceanography. So more on the life. Okay, from the word itself, biological, bio means the life in the oceans. And deep sea ecology and marine pollution are also the other two major important areas of study under biological oceanography. Next is the geological oceanography. So, geological oceanography is a division of oceanography that mainly dealing with the basic concepts of lithosphere and hydrosphere. No. And the word itself, lithosphere is the land, no, na portion, and hydro is for water. This includes the study of the oceanic crust, the continental margins, ocean bottom relief, ocean basins, oceanic ridges, reef valleys, island arcs, seawater, marine sedimentation, the geology and corals, beach forms and processes, water masses, the factors affecting the ocean circulation, waves and currents, no, the tides, energy coastal erosions, the drifting of sediments, no, sea level changes, the positional environments, and the marine deposits. So the geology of the oceans are being studied of this one from the word itself. land masses, the layers of the oceans, no, labi na sa katong boundary sa land and the water, no, the tides, no, the causes of tides, the causes of currents, no, the movement of the crust, no, volcanic eruption under the ocean. So those are the major studies, no, in oceanography. And geological oceanography is also concerned with the occurrence of oil traps and energy sources. This one, no, tectonic movements and underwater eruptions. So muna akong i-discuss sa ganina. Mud volcanoes and the impacts of tsunamis, no, are also concerned in geological oceanography. So let's go now to the part 3 of this material, which is all about the essential aspects of physical oceanography. Listed here are the aspects that needs to be considered when studying physical oceanography. So these fields are being studied by the oceanographers, no, when it comes to the physical aspect. First is the physical setting of the seas and oceans. The other one is the historical oceanographic explorations. Of course, no, they need to, before they study the other aspects of physical oceanography, they need to study first the historical aspect, the expeditions, the explorations during the ancient times, before they do the study or the researches in the present. Next is the instruments used in oceanographic studies, no? They need to know the instruments and the capacity of it, no? Kung unsa nga data ang pwede mag-gather, and unsa ray capacity ana niyang instrument, unsa ray data sets na iyang makuha, and so on. Also, the other aspect is all about the atmospheric influences of oceanic water masses, the oceanic heat budget, the temperature of the water, the salinity and density of oceanic masses. Next is the equations of motions, an equation of motion with viscosity. When we say viscosity, class, it's the flow of the water or the motion of the water. And next is the air-sea interference and response of the upper oceans and winds. We have also the geostrophic currents and wind-driven ocean circulations, the vorticity, no, and deep circulation in the ocean. We have also equatorial processes and their effects, no, kung mag full moon, no, unsay mahitabo, no, if mag new moon, if mag first quarter, second quarter ang moon. Of course, there is a gravitational attraction between two masses, no, the earth and the satellite, which is the moon, no? So naaya po na sila gravitational force, no? So kung sa effect pag full moon, no, or if the earth and moon is in a linear, no, or nag-straight sila, no, or nag-line sila, unsay mahitabo sa labi na sa equator nga part, no, kay murag mo ay mas duol, no, or kumbaga mas dako og gravitational force dito nga part kay sila ang na-direct na mura og hindi siya yung direct but sila ang mas duol og distance with each other, no, sa moon and sa earth. The ocean waves and tides is also essential, no, in studying physical oceanography. Numerical models, coastal processes and ocean induced hazards. So those are the essential aspects, no, that needs to be considered in studying physical oceanography. So these courses or these subjects and or aspects rather, no, is very important and it would be a very appropriate to understand. Dapat himay-himayon jud na sila na mga aspects so that we can really understood what is the essence of studying oceanography. Also, the evolution of the subject of physical oceanography by knowing it through some of his historical explorations made by the people. Magsugod man jud dapat sa history kung unsay nahitabo before, no, so that we can link those historical aspects and pag malink na to siya, then natin makuha na information. So, magamit na to na siya as benchmark for further researches. Next is for the part 4, which is all about the physical setting. So, the oceans daw are very thin layer of masses when we consider them in a global scale. No? Thin layer lang siya, kaya syempre sa ilalom sa water is naman siya po land masses. It's stated here that the vertical scale is very small when compared to horizontal scale. No? Kung atong i-compare si vertical, no, ang iyang depth, and i-compare natin siya sa horizontal scale, which is ang kalapdon, no, is very small. No? Gamay lang siya. Therefore, for all geographical representation, the vertical scale is to be exaggerated. So, para mas ma-interpret, so ang uban na researches, no, and also references, they need to be exaggerated so that we can really understood in a graphical representation or graphical manner. It also stated here that the ratio of depth and width of the ocean basins is also very small. Since atong discuss sa ganina, no, ang vertical scale is very small compared to horizontal scale. Therefore, ang ratio po sa depth and the width of or the width of the ocean is very small. So, this ratio daw is very important for understanding the ocean currents. The vertical velocities must be much smaller than the horizontal velocities. Again, the scale, the depth, and the velocity, no, is very small. No? Vertical scale, depth, and velocities are very small compared, or kung di siya very small, is smaller, no, than the horizontal scale, ratio, and velocities. And a very small amounts of vertical velocities may be great influence on the water turbulence and water bodies. So gamay lang ang movement, gamay lang na changes in velocity of the vertical velocities, it could lead to a great impact and influence on the water turbulence in a specific water body. So let's go to the discussion of the world's oceans and seas. It's stated here that the Earth has only one large marine water mass. Isa ra na sila tanan, tuyok ra na ang flow sa water. So di ba sa inyo ato ang maybe elementary years or high school years, the teacher introduces us on the water cycle. So as the water cycled, ma-recycle naman dyan siya, okay, ma-evaporate, ma-condense, ma-ulan, maato na po sa other places. But according to this book, that the Earth daw has only one large marine water mass. So isa ra jud na siya. And or kung dili man siya isa, kumbaga magtuyok ra jud na siya, no? And according to this reference, that it since isa naman siya ka-large nga marine water mass, but it was distributed in many forms such as seas, ocean, gulfs, straits, basins, and bays. So pero connected ra gyapon na sila, no? So matubigan na gyapon na siya, mahubas, matubigan na po. And the total area covered by these water masses is being 361 million square kilometer. Ingana kalapad ang atoang or ingana ang area no, nga na-cover sa water masses around the Earth. And it has a total volume of 1,370 million cubic kilometers. So, ingana ka dako ang volume po, estimated volume. It is higher than the volume of land above the sea, which is only 130 million cubic kilometer rather. So kung ato siyang buhatan og surface, no, na equal tanan ang sea and land ang mulapas adtong above the sea nga land masses is only 130 million cubic kilometer. The total land mass of the ocean is being 1.5 times 10 raised to the power of 18 tons, no? Which is approximately 0.25% of the mass of the Earth, no? So according to this source, 0.25%, no, are the mass of the oceans, no, with respect to total mass of the Earth. And there are 5 major oceans in the Earth. So kabalo naman siguro tani kay this was taught to us during elementary and high school years, no? 5 major oceans: the Pacific, Atlantic, Indian, Arctic, and Antarctic oceans, no? And all these water masses covers about 70.8% of the surface of the Earth. So 70.8% covered by this water. So when talking about the dimension of the oceans, so the dimension of the oceans according to this source may range from 1,500 kilometers to 13,000 kilometers along latitude and longitude. And the minimum width is 1,500 kilometer that is seen in an Atlantic Ocean along east to west direction. So ang iyang width daw kuno sa Atlantic Ocean in an east to west directions along longitude is about 1,500 kilometers, and it extends to more than 13,000 kilometer along its north to south extension, no? So here have height, no? So it will be 13,000 kilometers from north to south extension. Then the surface area of the Pacific Ocean is being 181.34 million square kilometers, and naa siya average depth nga 4,282 meters. Next is the Atlantic Ocean that has a surface area of 106.57 million square kilometer, and naa siya average depth nga 3,926 meters. Another one is for the Indian Ocean that has a surface area of 74.12 million square kilometers and has an average depth of 3,963 meters. And the overall average of the depth of the oceans is being 3,800 meters. Kung atong i-average ang depth sa tanan oceans, no, at sa katong 5 major oceans is 3,800 meters. If we look at the depth of the region throughout the oceans, we can see that majority of the area is occupied by the depth of the zone between 2,000 to 6,000 meters. No. Majority na ana nga range. But the deepest zone beyond 6,000 meters depth are noticed only in a few places in the West and Northwest Pacific or Midwest Atlantic, and a few isolated spots in Indian and other oceans. So kani nga mga ranges, no, or lapas pa sa 6,000 nga depth is makita sa kaning West and Northwest Pacific, Midwest Atlantic, and few spots from the Indian Oceans. For seafloor features, no, bathymetry is the when we say studying of the seafloor features, it will link into the bathymetric data sets or the bathymetric survey. When we say bathymetry, it is the mapping of ocean water column, and it provides a depth-wise relief features. Ang output sa bathymetry is depths, no, of the waters. The depths of the waters are measured using acoustic echo sounders, no, using this technology. So din na mosulod si hydrographic survey that is housed in a ships and altimeters housed in satellites. We can use echo sounders using ships, and we can also use altimetry, satellite altimetry. And bathymetrically, the relief of the ocean is divided into distinctive regions such as continental shelf, continental slope, and the deep ocean basins. And all these regions are unique physico-chemical and biological conditions. Okay? Since each locations or each place kung asa na to makita ang kaning continental shelf, ang sloping part of the continental shelf, and the deep of the ocean basins is different or unique, no, when it comes to physico-chemical and biological conditions. Seafloor features are also characterized, no, by distinct geological features in the Earth's processes. It's part of the analysis. No? And next is the morphology and relief of the seafloor include a wide variety of features. That includes submarine canyons, deep sea fans, abyssal hills, abyssal plains, mid-ocean ridges, deep sea trenches, sea mounts, no, rift valleys, ocean fractures, oceanic throws, and island arcs. No? So these are the variety of features, no, na pwede nato or pwede i-characterize, no, to have a seafloor morphology. Another aspect of the physical setting of the oceans are the crustal plates. No? So way back on our geology subjects, no, we all know that the earth crust is being broken into various lithospheric plates, no, mga tectonic plates nga itong nahibawan. And these lithospheric plates are moving relative to each other. They might be convergent and divergent, no, in movements of the plate. And these movements are, or the both movements, no, of those lithospheric plates are responsible to create new ocean floors at one side and subducting the ocean floors at the other side. So they are the one to responsible, no, kung na subducting, and the other one is creating another lithospheric plates. But altogether, the relief of the oceans are under dynamic changes due to these continuing tectonic movements. So if there are changes or movements of the lithospheric plates, the oceans are also being dynamic in nature. Another aspect that the reason why the oceans are being dynamics are the volcanic eruptions, no, earthquakes under the sea, rift valleys, and rising of ridges, crushing the continental margin materials, tsunamis, no. So these are being expected, no, during the processes of the movement, or these are the output or the result if there is a movement of lithospheric plates. We all know that, no, since we have studied this one in our geology subject. Alright, so let's go to the part 5 of this material, which is all about the effects on sun's radiation. So there are all dynamic processes in the oceans are directly and indirectly controlled by the sun's radiant energy and the atmosphere. Since kay walay obstruction at the sea, so direct kay siya from sunlight, so there might be, or there should be an interactions, no, on the sun and the oceans, no? And these are being controlled by sun's radiant energy, no, in the and also the atmosphere. So there are cycles maybe, or changes of the matters, no, which can be lead to certain processes or cycles such as the water cycle and among others. And the dominant mechanism of the role of the sunlight, and also the evaporation of the seawater, no? Infrared emissions from the sea surface, and the cooling or warming of ocean waters. So these are the some or no. Yes, some maybe, no, kay daghan pa man siguro yung mga processes nga ma-involves and mechanisms, no, when it comes to sunlight and seawater. But these are some: evaporation, infrared emissions, and also cooling and warming of ocean waters. The atmospheric circulations are controlled by the oceans, and the ocean water circulations are controlled by the atmosphere. So all the processes and mechanisms are being controlled in the atmosphere. Oceans are also dominant sources and sinks of the heat. The oceans can absorb, re-emit, store, and transfer heat energy or heat, no, very effectively by its constituent water masses. So if there are interactions, might be mechanisms, and the oceans can absorb, re-emit. Those are the processes that can be involved during the effects of the sun's radiation. So, tackling about the solar heating. So, when we say solar heating, it is an uneven energy source, and this uneven heating controls the strength of the direction of the winds and the atmosphere. So, if there is a solar heating, there might be changes, no, in the strength and direction of the winds in the atmosphere. Maapektuhan man jud siya. And the loss and the gain of the heat may by the oceans produce winds in the atmosphere. If there are changes in losing and gaining of heat in the ocean, according to this reference, no, this can produce, no, winds in the atmosphere. There might be mechanisms such as evaporation and condensation. These are the two more mechanisms enacted by the heat in oceans and cooling in the atmosphere. So, na solar heat, or if there is a sunlight, no, and the heat transfers into the atmosphere down to the seawater. So there might be an evaporation mechanism, no, where the water droplets or the water molecules, no, evaporated in the atmosphere, then form a clouds, then mag-condense din siya dito, then precipitate balik. And there are about 50% of the solar energy reaching the planet Earth is being absorbed by the ocean and by the land. 50% from the sun. Mao na siya ang mga 50% solar energy, ang 50% na lang, no, sa solar energy from the sun can reach into the planet Earth. And this is being absorbed by the land and the oceans. And 1/5 of the solar energy absorbed by the ocean is released back to the atmosphere. So from the 50% na absorb sa oceans and the land, only 1/5 of the solar energy is being released back again to the atmosphere through evaporation and infrared radiation. The balance is then transferred into the sea and is used for producing currents. And the heat flux is the transfer of the heat across the ocean and along the sea surface. And the flux of heat on the water also changes the density of the water and its buoyancy. It is estimated that about 4,000 joules of energy is required to heat 1 kilogram sea water by 1 degree Celsius. Sabi siya, no? They ang required, no, para maka heat og 1 ka kilo ng seawater by being 1 degree Celsius. 1 degree Celsius pa jud na siya is about 4,000 joules of energy, no, which is come from the solar energy. So what would be the effect, no, if there are solar heating in the oceans or the effects of heat in the oceans. Stated here that the Earth daw kuno is gaining the heat at the top of the tropical atmosphere, so which is located at the equator. Okay, since every day naamantay sun na makita no sa tropical countries, and the heat is loose no at the top of the polar atmosphere. Okay, since pa-cold naman dito nga part na aspect, so therefore and also no wala pod sila dili pod sila ma-strikean og sunlight no when compared to equatorial or the tropical atmosphere or tropical countries. The isolation is the term denoting the incoming solar radiation. A term denoting incoming solar radiation is isolation. Isolation is determined by latitude, season, time, and day of and cloudiness. It's stated also here that the polar regions are heated very less when compared to tropical countries or tropics. Okay, since in tropics or tropical countries we experience solar heating. Okay, kita may mas direct sa sun kay everyday makita man tag-adlaw. And we have also north-south movement that is called meridional heat transport. From north to south, movement of heat is what we call meridional heat transport. Areas in winter are heated less than the same area in the summer. So winter daw is gamay lang ang heat na ma-experience compared to summer. Kaya ang summer is bantang magid kayong init mo, taas kayong adlaw. Then the heat in the morning time is less than the noon hours, no? As expected. Mas init kung udto compared sa buntag. Moro yung kasabot. Then there is no insolation at night. Gabi na, wala na may sun, so walay solar energy. And all these have an impact on temperature of the water in seas and the oceans. So kung morning, dili init, pag udto mas init, so it can affect to the temperature of the seawater. Mura iyang buot kasabatan. So due to solar heating na high and low atmospheric pressure zones are also created. Warm and cold fronts are generated out of these changes. Muna natin ma-experience ka ng tail end of cold front. No? So that's one example of atmospheric pressures. So also solar heating is one of the aspects no na naaying anak nato nga ma-experience. The atmosphere within 100 meter above the sea surface is influenced by turbulent drag of the wind. So mas kusog og hangin no? Which 100 meters above the sea surface. And this layer of atmosphere is also called boundary layer. The layer that is 100 meter above the sea is what we called the boundary layer. So maka-experience ka dira og turbulent drag of the winds. Talking about winds, no? The wind measurements in seas and oceans have made for several centuries. No? So unang panahon pa lang, they have tried no on the measurement of the winds, no? Specifically in oceans and seas. And we have also the world's oldest wind reports that was made early in 1855. No? Muna pinaka-oldest na wind report na tally. No? And wind speed were understood through a convenient system of reference that is proposed by Sir F. Beaufort in 1806. No? So, ang measurement or ang wind reports during 1855 is based on the system na gi-propose ni Sir F. Beaufort. So, ang tawag po ana niya no, sa pag-measure or reference what they call this one? Measurements rather no, of the wind is what we call Beaufort wind scale in honor to the Sir F. Beaufort yung nag-propose nga reference or when measurement as reference in the oldest wind reports. And this scale is a graded level of denoting the force of the wind and its impact on water on the land. It helps to know the severity and intensity of the wind on the sea. Siya graded level that could denote the force of the wind na nai-impact sa water and also in land. And the force level of the Beaufort is a Beaufort wind scale is ranges from 0 to 12 representing calm wind and hurricane on water masses. So 0 means calm wind or kalma lang, and 12 being the hurricane na siya. And later, the condition of the sea were also determined using the modified Beaufort wind scale that was proposed by Kent and Taylor. And weather observations on ships, including the Beaufort wind force, are being measured. That is around 4 times a day. Normally, 4 times a day all over the world. So, since 4 times naman, these are done in 0 hours or in the midnight, 6 a.m., 6 in the morning, 12 noon, and 6 p.m. at local times. Kaya kaupat man siya i-observe in a day. Alright, so let's go to the part 6 na of this material, which is all about the ocean water properties. Alright, so the properties of the seawater are very essential aspects of physical oceanography. So aside from its historical observations, physical observations, the properties that are present on that specific ocean or seawater is very essential to be studied so that your goal in the studying of oceanography is being complete or satisfying. The seawater has a certain physic-chemical properties which plays a very significant role in hydrodynamics and also in the marine life. So these notable properties are temperature, salinity, density, and light penetration. And temperature and salinity measurements with reference to the depth are done using bathythermography, expendable bathythermography, and Nansen bottles. So first property that we are going to discuss is salinity. Salinity, when we say salinity, it is the total amount of dissolved solids present in the seawater. And this was represented as gm per kilogram of seawater. And this quantity is being dimensionless and usually ranges from 34.6 to 34.8 parts per thousand. And salinity also indirectly determined based on the conductivity and chlorinity of the water. So indirectly siya nga ma-determine, that is usually based on the conductivity of chlorinity of the water. So when seawater daw contains a higher concentrations of all the cations and anions. However, sodium and chloride are the dominant species present in the seawater. Conductivity and salinity are measured using conductivity meters. So ang salinity of the water can be measured using conductivity meters. And talking about the mean of the salinity of the oceans all over the world, it is found to be 34.7. So next property that we are going to discuss is all about the density of the seawater. The density of the water at the sea surface is typically being 1,027 kg per cubic meter. And anything that changes that will made on the density of the seawater will generate a vertical movement of the said seawater. And the turbulence in the mixed layer, or tama lagi, no? Turbulence in the mixed layers mixes the heat downward. And the flow of the heat, evaporation, rainfall, river, water inflow, the freezing and melting of the ice at the sea, all controlled the distribution of the temperature and salinity of the water in the oceans. So, sabtan naman siya, no? Ang flow of the heat daw kuno, the evaporation, rainfall, etc., including the melting of the sea ice, this was controlled, no, based on the temperature of the seawater and the salinity of the ocean water or seawater. And the changes of these two properties can increase or decrease the density of the water at the surface, no? Changes daw kuno in temperature and salinity. If there are changes of these two properties, it will lead into increase or decrease of density of the water. So, density of the water or seawater also promotes convection. This means that when the surface water sinks into a deeper ocean, it creates much pressure variation to generate ocean currents. Another property is the temperature of the seawater. The sunlight hits the seawater. We all know that. Kay bantang man jud siya. And this warms or these effects or this leads to the warming of the sea surface or surface layers that provides the energy to all the phytoplanktons and helps in the navigation in many marine animals. Of course, kung si sun, di ba, ato na siyang i-discuss or gitudlo sa tuwa before sa atong mga science teacher that the sun is the source of energy. So therefore, if the sunlight hits, no, the seawater, it will provide also energy to phytoplanktons and other marine animals. Warmest ocean water exists near at the equator and the coldest water exists at the poles. We all know that, no, kay pag naa ka sa tropics country or tropical country, mas bantang ang init, no? Dool man sa equator, and mas bugnaw sa poles kay tungod wala kay sila ma-experience the sunlight dito. So the mean temperature of the ocean water daw is being 3.5 degrees Celsius. Below the mixed layer, the water temperature decreases rapidly with the depth. Kung magkapadulong na ka sa pinakalawong mga part sa oceans or sea, mag-decrease ang temperature. Imubugnaw naman siya. Talking about light penetration, it states here that light penetration and absorption of the light by oceanic waters are very important aspects for marine life to survive. Dapat makakita po sila og sunlight. Ma-penetrate dapat makaabot pa sa ila ang sunlight kay para ma-survive sila, no? Na sila energy na makuha from the sun. Next thing that we need to discuss is the air-sea interface. So this air-sea interface is a very unique zone in the Earth. It is the zone which will have the maximum atmospheric influences. These atmospheric influences come due to sun's radiant energy on one side and the wind-driven water movements at the other side. Sabtan naman siya ang statement. Moving on to the part 7 of this material, which is all about the forces acting on the masses. The forces that are very essential, no, to be understood also in studying physical oceanography. So, first, diba itong i-discuss sa ganina is ang physical aspects or the physical setting, including its historical explorations and expeditions. Next is the properties of the water present and in the seawater, no, rather. And this one, no, another na po na to nga essential aspects nga needs to understand is the forces that will act, no, with the water and or sea water or ocean waters. So these are gravity, friction, and Coriolis force. So these forces, or we all know that forces are vector in quantity, and they have both when we say vector, diba, naana siya yung magnitude and direction, and the gravity is the dominant force that needs to be considered. The weight of the water in the ocean generates pressure, and due to solar and lunar influences, the tides, tidal currents, tidal mixing was happened, no, in oceanic waters regularly. So, muna kong gigawin na, no, due to gravitational attractions between moon and the earth, there are tides na may tabo, may current, naapoy mixing of all those, no, currents ba siya, na mag high tide ba siya or low tide ba siya. It will happen to the ocean waters regularly. The buoyancy is another parameter to be born in oceanography. When we say buoyancy, it is the upward or downward force arising due to Earth's gravity. Buoyancy acts on the parcel of water, and density plays as catalytic role in acting the buoyancy. And horizontal pressure gradients are also created due to varying weight of the water in the, different parts of the oceans. And the friction or fraction of the wind that blows, no, over the waves, the force of the water movement and air movement over the water may create the frictional forces. So due to the effect of the external forces, wind, no, air movements, waves, no, this will create two frictional forces. And wind stress is also created due to this motion. Movement nahimo siya og also the wind stress, no, can be created due to the motions nga nag-enact, no, which is atong discuss again. And in addition, pseudo forces and Coriolis force are also acting on ocean waters. So when we say Coriolis force, this results from the motion of rotating coordinate systems. When we say ocean water circulation, this includes the origin and the movements of the waves of the currents. So below, listed here are the types of circulation that can be seen in the oceans. First is the general water circulation. This water circulation is a permanent and is a time average circulation. Another one is the deep water circulation that is driven by mixing in the deep ocean. So usually this was from the word itself, no, deep water. So this was located in the deep part of the oceans. Another one is the wind-driven circulation. This is caused by local winds on the surface of the ocean. Another one is the gyres or gyres, no. This is also a wind-driven circulation that can be cyclonic or anticyclonic currents of giant magnitude. Another one is the boundary currents, no. These currents flowing parallel to the coast, no? When we say parallel, no, this can be or if you see a currents that is flowing, no, parallel to the coast, these currents can be called boundary currents. Another one is the jet streams or squirts, no. This is a long narrow currents with dimension of a few 100 km perpendicular to the west coast. And lastly is the mesoscale eddies, no. These are turbulent or spinning flows running for a few 100 kilometers from the shoreline. So let's proceed to the motion with viscosity. The role of friction in fluid flows and the stability of the flows to small changes in velocity or density are to be understood in the physical oceanography, or the movements or the motions of the water, the fluid flows is very important, no, or it's a precious one in understanding the physical oceanography. So when we say viscosity, it is a tendency of a fluid to resist shear, no? And the influence of viscosity, especially in the molecular viscosity, which comes due to the striking of water with solid mass, is to be analyzed. And the components of stress at a point in a fluid having pressure includes normal stress and other shear stresses. So when talking about these stresses in the water, so this can be taught, no, in your fluid mechanics, which is under the mechanics 2, if I'm not mistaken, in your new curriculum. Next is the turbulence, no. It is an important aspect in ocean waters, and turbulence is also affected by, or turbulence is caused, no, from the molecular viscosity. And the turbulence in the oceans can lead to mixing, no, because the ocean has a stable stratification, vertical displacement must work against the buoyancy force. Then the vertical mixing requires more energy than horizontal mixing. It's because usually ang motion sa water, no, sa oceans, as you have observed, no, which kung kintahin ba itong beach, no, sa imong ma-observe, mas kusog ang motion in the horizontal aspect than the vertical aspects. The vertical mixing is very important in oceans as it brings up the deep water some regions upward, no? Or importante yung vertical mixing or the movement of the water in the vertical aspect. Also for the temperature, no? Example sa temperature, di ba mas init ang naa sa babaw compared sa ubos. So kung na vertical mixing, mabalance ang iyang temperature sa oceans. Then let's proceed to the stability of the mass, no? In oceanic waters daw, stability is yet another parameter to be understood. There are many kinds of instability occur in these water masses. These kinds of stability includes static stability, dynamic stability, and double diffusion. So these kinds of stability can be understood or essential to be understood in studying physical oceanography. The static stability is associated with changes in density with depth. And when we say dynamic stability, this is associated with velocity shear and double diffusion. And also, double diffusion can be associated, no, with salinity and temperature gradients in the oceans. So we have also what we call Ekman layer and Langmuir currents. So it's stated here that the steady winds blowing on the sea surface produces a thin horizontal boundary layer that is called Ekman layer. So, syempre na ay wind sa oceans, no? And that is blowing the ocean surface, no? And this produces a horizontal thin and horizontal boundary layer. So, ang tawag na nga layer is Ekman layer. So, this layer may be of a few hundred meters in thickness. So, Ekman layer transports water at the right angles to the wind, no, directions, and subsequently generate upwelling. And these upwelling motions enhances biological productivity to feed the fishes and other marine life. And there are also deep ocean Ekman layer near the sea floor. So dili lang kay sa ang Ekman layer is makita lang nato siya sa, or ang boundary dito sa boundary layer, no, sa horizontal boundary, no, or a thin layer na makita nato sa surface sa ocean, but also there is what we call deep ocean Ekman layer, which is dool na siya sa sea floor or ocean floor. A current that is spiral around the axis parallel to the direction of the wind is called Langmuir circulations. So Ang current nga mo-occur dito sa Ekman layer, no, that produces produces a spiral, no, and also or a spiral around an axis parallel to the direction of the winds is what we call Langmuir circulation. So it is customary to think that ocean currents are driven mainly by winds. So we all know that, no? Ang ocean currents or ang kanang mga waves, so those are driven by the natural winds. And currents and ocean circulations are driven by not only a wind but also other factors and forces caused by site location and space on the globe. Also, katong discuss sa ganina na itong mga or from the previous slide, that's the tectonic plates, motions, no, volcanic eruptions. So those also are other forces that can act, no, in producing currents in the oceans. So we have also this what we call geostrophic currents, no? So ang role niya is yet another mechanism in physical oceanography, or another aspect to be considered in physical oceanography. The theory of wind-driven geostrophic currents was studied by the scientists Sverdrup, Stammel, and Monk, no, between 1947 to 1951. Satellite altimetric observation of the oceanic topography can give time-variant data of surface geostrophic currents. No? Mga satellite altimetry like can produces topography or elevation, no, under the sea or the oceans. It can be studied through satellite altimetry. Then hydrographic data are used to calculate the internal geostrophic currents in the oceans, no, which can be gathered using hydrographic surveying, echo sounder or echo sounding, no. So this hydrographic data, or the data that you gather during those hydrographic surveys, can be essential, no, in calculating the internal geostrophic currents. The flow in the ocean that is dependent on the depth is what we call barotrophic flow. No? Ang flow daw sa ocean independent, no? Independent sa depth. Di siya magsalig sa kung unsa ang kalawman sa tubig, no? So that's what we call barotrophic flow. And in contrast, no, ang flow daw nga nag-depend on the depth or the kalawmon sa oceans or seas is what we call baroclinic flow. And baroclinic flow can be determined using hydrographic data. Okay, since nag-depend man siya sa water depth. So below are the several types of the ocean currents, no, that is existing in our oceans, no. So first is the Antarctic circumpolar currents. Second is the deep ocean density driven current. And we have also these western boundary currents that can be subclassified by these currents, no. We have Gulf Stream, Kuroshio current, Labrador current, Oyasho current, Agolhas, no, or Agolas current, no, Brazil current, East Australia current. And we have also eastern boundary currents, no, that is subclassified by California current, Canary current, Peru current, and Benguela currents. Let's proceed to the vorticity. No? When we say vorticity, no, according to our discussion from the previous slide, it is the rotation of the fluid or the movement of the fluid. So there are two types of vorticity. This is planetary vorticity and relative vorticity. And when we sum those two types of vorticity is what we call absolute vorticity. And vorticity can be strongly influenced by ocean dynamics, no? Since the water in the oceans are very dynamic, no? So this can be influenced, no, by this ocean dynamics. The curl of the wind stress adds relatively vorticity to central gyres of each ocean basins, no. So water can be rotated in the oceans, no, And we all know that if there is a wind, or the curl of the wind, or the stress of the wind, can be a aspect, no, so that the water can rotate on its natural way. And in oceanic waters, rotations and conservation of vorticity strongly influence the flow over distances exceeding a few tons of kilometers. So again, mato kong discuss sa ganina, no? This was influenced by the winds and other forces acting on the ocean masses. We have also these equatorial currents, no? The deep circulation in the ocean is also an aspect to be understood, no? So di lang pwede na sa surface lang ang mga circulation, but also in the deep portion, no, of the oceans. The equatorial currents moderate the air-sea interactions through the phenomenon that's what we call El Nino, no? El Nino. Equatorial currents, no? Kay since mas present always ang sun, no, every day, kita naanta sa tropical countries, no, or near the equator. So every day we can experience a heat, no, from the sun. Okay, mas duol ta compared sa North Pole, no. So stated here that equatorial currents daw moderate the air-sea interactions, no? That's what we this phenomenon is what we call El Nino. El Nino is from the acronym word the child Jesus. These are found to be countercurrents existing along the Peruvian coast. And the east-west temperature gradient on the equator drives the zonal circulation in the atmosphere. And this circulation is what we call Walker circulation. East-west, no, nga temperature gradient is what we call zonal or ang zonal circulation that occurs on that specific temperature of the east to west, no, is what we call Walker circulation. And El Nino denotes a disruption of the entire equatorial system along the Pacific, and this causes the changing weather patterns around the globe, no? So kasalit naman siguro taon sa ng El Nino, no? El Nino kanang long period of drought, no, kanang walay ulan jud nga ma-encounter sa specific place. So unsa may tendency or unsa may effect niya sa place, no? Of course there is a changes of weather, no, patterns. Dili na to na ay changes nga since long man siya nga period of drought, no. So di siya pasabot na every year is naa siya El Nino, no. Mo come up na siya kay it's a phenomena, no? dili siya permanent occur in the specific place every year. Phenomena man siya, so tagsara siya mo occur. So this will cause weather changes of the specific place, no. May say for example sa equatorial countries or tropical countries such as the Philippines, no. So if maka-experience sa og El Nino sa Philippines, no, sobra kainit ang temperature na sa tubig sa equator. So kung sobra na kainit, no, mo laganap na din siya padulong sa North Pole, no, which causes no nga heat or melt ang mga icebergs or ices near the North Pole. So mao nang changes sa climate or sa weather, no? So when we say El Nino, it's the term, no, that is related to Southern Oscillation or ENSO. No? It is a sea level pressure anomaly in the eastern equatorial Pacific region. So El Nino occur ni siya sa katong na ay maka-experience of heat sa sun, no, such as tropical countries or near the equator countries. No? The tropical and equatorial Pacific is a vast ocean, and it is a remote area which is seldom visited by ships. No? And El Nino causes the biggest changes in equatorial dynamics. No? And during the El Nino, trade winds weaken in the Pacific, Western Pacific. Kung na El Nino daw, ang wind is mo weak, no, in Western Pacific. And El Nino can generate the Kelvin wave, no, eastward along the equator. padulong sa east. And these are the largest sources of annual fluctuations in global weather patterns. And due to this drought, no, na nahitabo in the Indonesian area and northern Australia. So, similarly, floods occur in western tropical America. So, kung naay maka-encounter og El Nino in the other side of the globe, the other side can experience floods. No? Okay, since ma-melt naman tong or di siya necessary na floods, but sea level rises. No? Okay, mabiton na isa ka issue karon no sa kanang global warming nga ilang giingon. If the Earth is still arising, no, or mas mataas pa ang iyang temperature, so there's a tendency nga ang mga ice nga na-locate sa near the North Pole can melt, no, and according to the researchers, no, that if the water melts from the North and South Poles, no, the sea level at the equatorial part will arise, no, or musaka siya. So this is alarming. Okay, what if ang katong mga sea level lang na mga elevations sa Philippines, no, kung water o mo increase pa gid ang water, so matabunan jud sila, no, or mahimo na jud tong dagat. So many environmental advocates, no, really doing their job or doing their advocacy that we need to have a action to this one. Okay, murag nagkainit na ang kalibutan. So ingana ang mahimong effect, no, if we will continue or atong i-continue ang pag-abusar sa ato ang globe or sa Earth. Alright, so much for the part 7. Let's go to the part 8 of this material, which is all about the waves, tides, and coastal processes. Now, in physical oceanography, it is a detailed study on ocean waves, tides, and their impacts in the coastal zone is very needed, or kinahanglan jud siya. Not only the physical aspects, but we need to understand the motion of these tides, waves, and other coastal processes. Ocean waves are powerful systems, no, shaping and reshaping the coastal zones. It can, di ba, makabantay mo anang kusog ang balod, no, or mo high tide, mo low tide. So, makakause siya og changes or formation in the coastal zone or in the shorelines. No? It's because the waves has an energy. No? And when we look to the sea from above, we can see 1,000 of waves in the sea surface approaching the coast. No? Or kanang simple lang maka-observe mo kanang mga ligo mo dagat or mag-beach mo. No? So, ma-enjoy man ninyo ang balod, no, or kanang waves. No? And if you are going to see it above or you are going to observe above, there are many waves that will approach in the surface or the coastline. No? And imagine, no, sa kadaghan sa waves, and that waves has an energy, so it can create you another study, no, or another interest na basin pwede na to i-convert ng wave energy into electricity, no? Who knows, di ba? And these are undulations of the sea surface with a height of around a meter or a few meters. Undulations or changes in elevations of the sea surface na mag-change man siya. And waves break if water is sufficiently shallow. Pag magkaduol na siya sa shoreline or sa coastal area, which is mumabaw na, mo-change ang iyahang or mag-break or mahuman, maputol, no? Or ang iyahang waves na. The broken waves pour water into surf zone, no? Creating a long shore or reef currents. Ocean waves or waves is a natural and outstanding phenomena of the oceans. So, mga question ta, nganong naay ocean waves? Nganong naay waves, no, sa oceans? And ma-answer nato na later on ngano na unsay causes ani nila. So wave phenomena is evolved in transmission of energy and momentum by means of vibratory impulses. For ocean surface waves, the direction of propagation is perpendicular to the wave crest in a positive direction. So later on nato nang i-discuss kung saan ning wave crest. Dapat tayo gitawag na wave throw. Later on sa atong slides. No? So ocean waves are produced by winds, no? Stated in here, no? So wind is one of the factors, no? Or one of the reasons why there is a ocean waves. No? The faster the wind, the longer the wind. The faster the wind, the longer the wind blows. No? So kung na winds na nasa oceans, no, mag-blow siya sa water, so it can create a waves. No? And the bigger the area over which the wind blows, the bigger oceanic waves generate. No? So kung mas dako or dako ang area, kung aha tong kusog na hangin, mas dako pod ang iyang waves na ma-generate. Observations by mariners on ships and satellites using sensors and altimeters help to prepare the global charts and maps of wave heights. No? Of course, no, by using the technology, which is remote sensing, can still be part of this study, no, in hydrography. So we can study that, or we can map, no, on where are the areas of the earth that has oceans and seas. We can see in a bigger waves, and which areas can we experience no waves or mas linaw ang tubig, no, sa locations. So we're going to discuss now the wave properties, no? So it's written here that each wave has a wave height, which is vertical distance between the bottom throw and the top crest of the wave. So murag ato nang naibawan diri, no, kanang wave bitaw nga, di ba ang wave is maka-realize naman, or imagine mo sa wave, no, kanang ana, no, wave. So ang top nga portion na niya is what we call crest, and the bottom part is the throw. The wavelength is the distance between two prominent adjacent crests or throws. No? Duha daw ka, or the distance between two prominent adjacent crests. No? Duha ka crest na tapad, that's what we call wavelength. Or you can also say that the two adjacent throws can be a wavelength, no? Or muna siya ang wavelength. And the wavelength may range into 50 to 100 meters. Imagine that, no? Ingana ka taas, no, ang wavelength sa oceans. When we watch these waves in a few minutes, we can notice that the wave heights and the wavelengths are not constant. So kanang mabantayan nimo sa dagat, or kanang mga ligo mo during mag-beach mo. So ang imuhang ma-experience na waves is dili gyud na siya parehas og height. It has different heights and different vertical heights. The waves that was approaching is not constant, and it is because they vary in space and time. No? The wave period is the time taken by two successive waves to pass through the fixed point. No? So ang wave period is katong duha ka crest niya nga ma-experience, or duha ka throws niya nga ma-experience. Of course, fix ang imuhang point, or kung ikaw mismo maka-encounter. So kung kuhaon nimo ang iyahang wave period, so mag-observe ka nga duha crest ang moagi sa imo, or duha ka throw. And all offshore waves are generated by winds. And it is also true that the sea level changes from hour to hour. So dili man siya nang nabitaw na gitawag nga uy high tide karon. Pagkahapon is mag-low tide. No, it changes. No? It's because the ocean is dynamic. So talking about so much for the discussion of waves. No? let's go to the discussion of tides. That is in addition to our discussion a while ago. It is also necessary to understand the coastal processes and tides. High tide, low tide, and others. Sea level increases and decreases during a day. No? So, muna itong gaganin na nga. Sea level, the sea level height or the sea level is changing, no? From time to time or hour to hour. The slow rise or fall of the ocean is due to the tides. No? Umusaka ang sea level, muubos ang sea level. So, this is due to the tides. Tides have wavelengths of thousands of kilometers. They are generated by a slow, very small changes in gravity as it is being influenced by moon and the motion of the oceans. Okay, since may mga gravitational force or gravitational attraction between the moon, the earth, and the sun. No? So these gravitational attractions enacted to this natural body, no? Which can be seen from the outer space. No? So this can cause, the tides or changes of tides. So let us proceed to the causes of tides. The gravitational attraction of the moon causes the oceans to bulge out in the direction of the moon. So we all know, no, as I have introduced a while ago, no, that the two artificial bodies, no, or heavenly bodies such as the moon and the earth has a gravitational forces. No, they can attract together. So the gravity or the gravitational force will be the reason why the moon is rotating into the earth, as well as the gravitational force that is enacted to the earth and the sun. No? That is the reason why that the earth is also rotating or revolving, revolving around the sun. No? So these two gravitational forces between the moon and the earth, no, kay since mas duol si moon kaysa kang sun, no, though naadya po gravitational attraction na nag-hold between kang sun and kang earth, no, but the higher gravitational force is really came from the moon. No? So siya may mas duol. So those forces that enacted between the moon and the earth will be the one that is caused, no, why the oceans is bulging or mas dako mas mabira niya ang water, no, kung asa nakalocate si moon. No? And when the oceans is bulging, no, or the part that where the moon is located, no, the oceans will bulge out, no, in relation to the direction of the moon. And another bulge occurs in the opposite side, since Earth is also being pulled toward the moon. No? Kaya since si moon is pull siya or nag-enact siya o gravitational forces, no, to Earth. No? So muna ang part na kung asa si moon na dito ay mas madaghan, mas pulled out niya ang water. But the other side, no, kay since kay si Earth pod is napod siya gravitational force na nag-enact to the moon, so nagya po'y water na mabilin sa pikas na part. No? And since the Earth is rotating while this is happening, there are two tides, no, na mo occur each day. So this is an illustration, no. We can say that the moon has a gravitational attraction or gravitational force, and also the earth has a gravitational attraction towards the moon, no. Kaya since si moon is mas duol siya kang earth, so there is a gravitational pull, no. Ang water sa earth mas bulge out siya diri sa part kung asa ang moon. So that's what we called high tides, no, or high tides. But the other side, no, dili pod pwede nga tanan na lang water is papadulong kung asa si moon. It's because the earth has also a gravitational force, no, towards the moon. So magbira po na siya, napod siya pool na gravitational pull na i-enact to the moon. So that's why naapa siya na bilindiri ang water. So that's what we call low high tide, or mas mabaw siya compared sa high tide, no? High tide, no? The periodic nature of tides is purely astronomical phenomena. Okay, it is caused by the heavenly bodies, no? And this result to the daily rotation of the earth about its axis and the annual revolution about the sun. So ang earth rotation, ang daily rotation sa sun, and the revolution of the earth, balik na. The daily rotation of the earth about its axis, so since kay earth is mag-rotate man siya, and there is also a motion, no, nga si sun, o si earth rather, is mag-revolve kang sun, and also the revolution of the moon around the earth, which is monthly, no? Kada month mahumanay ang iyang revolution. So these are the reason why there is a periodic nature of tides, no? That is really that was stated here that it is really purely astronomical phenomena, no? Let's recall this formula, no? The gravitational attraction that is varies as the square of the distance between the earth and the moon, so that the portion of the earth's surface nearest to the moon is attracted more powerful than the central portion, no? So this formula, no, F is equals to gm times m all over r squared, no, where m or g is the gravitational constant, which is this value, no, 6.67 times 10 raised to the power of -11, and mass of the one object, no, in this case this is the moon, no, and m na gamay is the mass of the other object, which is the earth, no, and r is the distance between those two objects, no. Nani sa inyong physical geodesy na discussion, no, the gravitational attraction. So this is the one where this is the real reason, no, or the reason why we experience the tides. We have here also the several definitions of tides, or the tidal definitions. First one is the tide. This is the half-daily cycle of the rhythmic rise and fall of the surface of the bodies of the water connected due to the gravitational attraction of the sun and the moon acting upon the rotating earth. No, half-daily cycle kay since every day there must be two types of tides that will encountered by the earth. No. We have also tidal current. This occurs in conjunction with the rise and fall of the tide. This is the vertical motion of the tides near the shore that causes the water to move horizontally and will create a current. And when the tide current moves toward the land, so kung padulong siya sa land ang tides, that's what we call floods. And if it moves towards the sea, or pabalik na siya sa sea na current, that's what we call ebbs, or ebb tide. No, say for formal definition, flood tide is the period which the water surface is rising and moving toward the shore. Padulong siya sa lupa. And ebb tide is the period of which the water surface is falling and moving seaward. Padulong sa sea or the oceans. We have also slack water. It is the instant in which the tidal current is changing direction and flows near, in, or out. Kanang magtagbo bitaw si ebb ug si flood tide, no, it can change or the instant tidal current is changing directions, no, from flows, or the direction and flows, no, whether it is in or out the from the shoreline. Here's the figure shows, no, the difference between the flood tide and ebb tide, no. Flood tide is padulong sa water, padulong sa land rather, and ebb current or ebb tide is pabalik. And slack water is the changing, instant change of the direction of the ebb and flood, or the changing in direction of the tides. So another tidal definition is what we call set, no? When we say set, it refers to the direction of the current flow, no? Kung asa padlo ang direction sa current, ang tawagan na niya is set. Another one is drift, no? It refers to the speed of the current flow, no? The speed ang speed sa current is what we call drift. Another one is the high water. It refers to the maximum height of to which water surface arises above the standard datum plane during the given period, no? Or in other term, it is what we call high tide, maximum height. Another one is the low water. It is the greatest depression, no, of the water surface below the standard datum plane during the given period. When you say standard datum plane, no, kana kung asa naka-base ang ato ang or kanang gitawag natog sea level, sa ato ang part or sa Philippines, no, we usually use the mean sea level. And low water is also also known as low tide. We have also tide range, no. It is the difference between the high and low tide, no, at a certain location on a given date, no. For example, for the day, no, sa isa ka location, like for example sa Masaw, no, ang difference between sa high tide and low tide, it's what we call tide range. We have also tidal day, no. This consists of idealized average period of 24 hours and 50 minutes between the occurrence of two successive high tides, no, of the same type at the same location. Tidal day, no, kay since duha man ta maka-experience, no, of tide, so it is the 24 hours and 50 minutes, no, between the occurrence of two successive high tides. We have also stand, no. Stand is the period at high or low water during the tidal cycle, no, when there is a little or no change in height of the tide, no. Stand kanang wala kay changes sa high tide of low tide, murag stable lang ang iyang sea level. The water level is at most stationary, so wala kay changes, and the tidal currents fall away at zero velocity before reversing, no. So wala kayo changes sa tidal currents. We have also another term that's what we call tidal waves, no. This is an exceptionally large ocean wave caused by the force of winds, typhoons, ocean floor movement, submarine earthquake, no. So this is what we have discussed, no, a while ago. And the tidal waves are not of astronomical origin, and thus tidal waves are not of astronomical origin and are thus actually misnamed siya kay kung mayngon pud taog ka ng astronomical, no, ocean waves na to siya, or ocean waves. And let's go to the tidal datums, no, kung asa naka refer ang ato ang tide or the heights, no, kanang gitawag natong vertical datums, no. So the specific tide when you say tidal datums, it is the specific tide levels used as reference for depth measurement in the sea and as a base for determination of the elevation of the land, no. Tidal datums or the vertical datums, no, nag-refer sa ato ang heights. So the principal datums are what we call MSL or the mean sea level, MLW or the mean low water, MLLW or the mean lower low water, and the MLWS or the mean low water surface. So when you say vertical datums, like horizontal datums, the measurements elevation only has the meaning when reference to some starting point, no? For example, this is your datum, no, kung asa nakabutang ang imong, or the vertical datum kung asa maka-reference ang imong height. So usually we have mean sea level, no? The mean sea level, it is the 19 years of continuous observation of the high tide and low tides, or the mean of all tides nga na-experience in 19 years, no? So para makaingon ka nga mean sea level ang imong ganito. MSL, it is the average height, or mean sea level, it is the average height of the sea for all stages of the tides, no? average height of the sea. Then MLW, it is the mean or the mean low water. From the word itself, it is the mean of all low waters, no? Low waters or low tides. And MLLW or mean lower low, it is the average of all heights of lower, no? Of the lower of the two low waters, no? Ang duha ka lower, duha ka low tides, no? Ang katong lower nga portion, lower nga part, mao to siya ang i-average, then mao to siya ang MLLW. No? Kaya di ba ang mean low waters is tanan low waters, no? Or below the sea level. And ang kaning MLLW or the mean lower low, it is the mean of all heights of the lower of two low waters, no? Ang katong duha ka low waters nga na-encounter, ang mean adto nila mao to siya, or the average adto niya is what we call MLLW. MLW S or the mean low water spring, no? Or mean low water spring, no? When we say MLWS, it is the mean of low waters during the spring tides, no? During the spring tides na siya, that occurs in a day or 2 day after new or full moon, no? Spring tides. That is obtained by subtracting 1/2 of the range of the spring tide from the mean tide level. So mo na siya ang meaning sa MLWS or mean low water spring. So this is the differences between the tidal datums, no? We have mean sea level siya, mean low water, no? Tanan low waters nga na-encounter iyatong height, iyatong puhaan og average. MLLW or mean lower low water. So ang katong duha ka low water puhaan og average, mo to siya ang MLLW. And the mean low water springs is the mean of low waters during the spring tides. And we have also the LAT or the lowest astronomical tide. Katong pinakaubos na jud nga na-encounter due time, na di lang sa isa ka period. So we have also tidal patterns, no? Tidal patterns natay tulo ka pattern. First is the diurnal, no? Diurnal is occurs when there is one high tide and one low tide per day, no? So kung maka-experience og isa ka high tide ug isa ka low tide sa isa ka adlaw, ang tawag na niya is diurnal pattern. We have also semi-diurnal pattern. So it occurs when two equal high and low tides per day. So duha ka high tide, duha ka low tide, that is equal. Tawag ito niya is semi-diurnal. And mixed is two unequal high tides and two low tides per day. So kung naay duha ka high tide pero dili siya parehas og height, no? And naapoy duha ka low tide pero dili parehas og height sa isa ka adlaw, ang tawag niya is mixed pattern. So this is the common type, no, of tidal pattern, the mixed one. So the next is tidal bores, no? We're going to discuss the tidal bores. When we say tidal bore, it is a tidal phenomenon in which the leading edge of the incoming tide forms a wave or a waves, no, of water that travels up a river or narrow bay against the direction of the water or bay currents. So usually this occurs when the conjunction or intersection of the rivers and the seas, no? Kay since lahi man sila og direction sa water, no? Like for example, ang river is padulong sa sea, and the sea has also the direction going to the landforms, which usually mahitabo siya is mag-intersect, no? And if there are two different currents, no, mag-form na siya dayon og bores or kanang gitawag og tidal bores. Ingani example niya, class. So basin kisan nakita ani, so maka-imagine din sila. Ang tawag ana niya is tidal bores. So let's go to the tidal gauges discussion, no? A tide gauge, it is an instrument used in measuring the height of the tide. So we have two types of tide gauges, namely non-recording gauges and automatic gauges. When we say non-recording, it requires presence of attendant to observe and record the height of the tides. Mano-mano ni siya nga pamaagi. Magulat ka dito, tanaw nimo ang i-record nimo ang kung sa siya nga time and day, pila iyang tide height. No? Another one is automatic gauges. This is a self-registering gauges. No? Mismo na ang system sa iyahang instrument ang mag-save sa data nga iyahang nakuha. So, in tide gauging or in measuring the tides, or usually siguro kasi na makitag ingani sa kanang kilid sa sapa or ng kilid sa dagat rather, no, or kanang sa mga tulay, no, usually makita mo ingani. So those are the tide gauges to monitor if nisaka ba ang tubig or wala, no, high tide ba siya or low tide. So in tide gauging, a special care should be taken in the selection of the tide station, no. Dapat kabalo ka kung asan mo ibutang, no? Dapat sa pinaka the best na location ibutang si tide gauge. And dapat is protected siya, no, from the falling debris or mga walking passengers or walking na mga or di mo dapat siya ibutang sa crowded nga places, no? Dapat safe siya. No? And there should be a depth of about 1.5 meters below the predicted lowest tide. So, a gauge should be located where it will not be damaged by the land or the sea traffic. So, dapat mo ni siya, no, kung dapat i-select ninyo ang pinaka the best na locations. So, we need also to discuss the tsunamis, no, which is important man gyapon ni siya. No? It is a coastal processes nga mag-occur, no? Aside naman siguro taon sa ng tsunami. No? Tsunami are yet another issue in oceans and coastal regions. The impact of tsunamis are very devastating. No? Damaging gid siya kaayo nga phenomena. Remember mo atong sa Japan na tsunami nga dako kaayo ang area nga na damage, no, due to tsunami. The recent tsunami have made the whole world population to think very seriously about natural disasters, no. Di lang kay flood, di lang kay earthquake and others, no, but also we need to consider this one as a damaging phenomenon or damaging natural disasters, no. Tsunami are low frequency ocean waves generated by underwater earthquakes, no. This is what we call as seismic sea waves, no? Or usually this was caused by the volcanic eruption under the water or the tectonic plates motion. The sudden motion of seafloor over distances of 100 or more kilometer generated tsunami with waves period of 15 to 40 minutes, no? So gikan sa itong location nga naay tectonic motions or volcanic eruptions, no? So this will generate, no, a tsunami with a period of 15 to 40 minutes padulong sa langit. So tsunami these propagate at a speed of 180 meter per second with a wavelength of 130 km in a water. Okay. Imagine kung sa kataas ang iyang wavelength 130 km. And tsunami may be 3.6 km deep and is not noticeable in the sea surface. So since kay sa underwater man nag-start, no, ang cause sa tsunami which is volcanic eruption or tectonic plate motion, kung sa layo pa lang dili pa nimo siya mabantayan. Mabantayan na nimo siya nga magkadako as it approaches near the land surface or land area. After nearing the coast, the surge may rise up to 10 or more meters above the sea level. So as it goes to the coastal area, makataas ang iyahang wave, no, as it surge to the land area. A tsunami can travel 1,000 kilometers and do a serious damage, no? So we all know nga kung sa ka dako or unsa ka damaging dili si tsunami. The first wave of tsunami is not likely to be the biggest, no? So ang first wave nga moabot di na siya mao ang pinakadako, no? It siguro sa ikaduha or katulo na nga wave mas mas dako pa jud na siya no way na atong ma-encounter. And next is the tidal energy. The oceanic tides produces strong currents in many parts of the oceans. Their speed may go up to 5 meters per second in coastal waters. And we all know that oceanic tides or oceanic tides has a great energy. So that's what we call tidal energy. Usually gani kay kani nga mga tidal energy is gina-studyhan sa mga scientists karon for producing a potential source of energy, for example for electrification and so on. They modify the coastal geomorphic conditions very often, and shorelines of submerged and shorelines of emergence are two important aspects related to these waves and tides. Submergence and emergence, padulong o pabalik. And coastal erosion, coastal sedimentation, and tidal inflow are all the natural effects of these processes. So kung naay padulong na tides, ma-change dayon ng formation sa land or the shorelines. Usually makabantay mo nga kanang ni atras or ni padulong sa isa ka ni atras or nakuhaan ang land area near the coast tungod na siya sa changes made by tides. Alright, so I guess this ends our topic 9 for this material, for this course which is the hydrography and hydrographic surveying. So for your questions and clarifications regarding this video lecture, you may message our FB page that was introduced during our video lecture for class orientation. And I hope that these video lectures will supplement you in studying the said subject and the course in times of pandemic or the COVID-19 pandemic. I really hope that you will study well, and you need to utilize these video lectures para mas masabtan pa ninyo ang hydrography na subject. Again, thank you so much for watching, and see you for more video lectures, even if it's not about hydrography and hydrographic surveying. Keep safe everyone, and have a good day.